This July 4th, America turns 250. Happy birthday, America, 2.5 centuries. So, here's a fair question for a manufacturing podcast. Walk in any job site in this country, anywhere you choose. Find the compact crane doing the tight access lifting in very restricted spaces and read the data plate. What do you think you'll find? Odds are it says made in Japan, Italy, Netherlands. This narrow segment of manufacturing where you have compact machines doing the heavy lifting is almost entirely imported. We build ours in Muskego, Wisconsin. Designed here, engineered here, built here. Is every part American? No. There's certain specialty components we can't source in this country. And we are not going to pretend otherwise. We have to import some things from Germany, some things from Italy, something from Asia. So that is a reality of manufacturing in the US today. But the machine is built here, and that is what uniquely qualifies us to compete in the build in America space, buy American work at all. An all import crane cannot compete in that space. For a service disabled veteran owned shop chasing federal contracts, this isn't a flag on the wall. It's whether you get to build. That's a qualification criteria. So, with that, Eric, let's talk about the machine, starting with the problem you can solve with the telehandler per se. Do a typical construction site where they're still building up the high-rise building, where installing glass is a very prominent portion of the construction.
Typically, they're building from the ground up. Before they build the next floor up, they usually have the materials for the lower floors already on the lower floors. So they've already flown in a large packet of glass or a large packet of drywall. They're already on that floor of the building for install in that location. So how do you get those pieces into specifically the glass? How do you get those into location when they're inside the building? Because you're not going to tie up the tower crane, lifting each piece of glass into place. It's just going to be much more time consuming. That tower crane is much more suited for lifting the heavier materials on the next floor up.
Okay.
So the beams, the structure, internal structure, concrete pieces, parts of that nature, which are much more suited for something with much more capacity outside of the building.
So if I can interject here, so high rises are not a novel thing. They've been doing we're right next to Chicago. They've been doing since a very long time. So does that, how they used to build back in the day, use a overhead crane to drop the glass in place?
No. Well, probably at the beginning where they didn't have any other tools, they were probably hefting them in by hand. To be honest, they had much more crew, much more labor involved, more potential injuries, of course, that go along with that. So what is the solution?
OSHA safety regulations, and then given the environmental consensus of how leads, is that what it is? Like the building has to be more efficient in energy consumption?
Right. That is a huge factor in the new high rises because the costs of energy, obviously, for heating and cooling are going up and up. And how do you reduce the amount of overall cost in the long term? You need to reduce the energy consumption or the losses.
So also like speed might be a huge factor. It's not like you're building high rises in the barren land somewhere.
No.
You have to decommission something and then put something up. I mean, literally time is money.
It's no longer taking 20 years. They're doing them in 5-10 years. So the speed at which you put stuff together is crucial. You've got a given timeline and you want to get it open and operating and start obviously making money.
Yeah, 5-10 years is new building, but especially if they have to refurb an existing building with replacing glass and everything, that time is like, ticking.
And then how do you do that? There's nowhere to put a tower crane next to the building anymore.
Because there's all kinds of buildings
parking lot. There's a building right next door within so many feet. Yeah.
Okay.
It's a lot of maneuvering to make it happen. And that's where the compact handlers come into play.
So they obviously they come with multiple attachments, a fork, a jib, a winch. So with the winch, given the capacity, we can even lift the materials into place when the crane is resting on the slab,
Right.
right?
Say you've got a piece of glass the glass is showing up later. You can reach down from the 20th, 30th floor down to the ground, hook up each piece and bring it up and place it into the building. That is an option.
I think it used to be like a huge deal. Now with labor laws, you cannot do it. How did people approach this problem back in the day?
A lot of it was manual labor and hand winches, and glass lifters have been around for a hot minute, for
Yeah.
sure. They've been around a number of years. So how do you get it up to the position? Well, they've been adapting smaller cranes to reach up so many feet. You can get probably up to the 10th floor, 15th floor. Shouldn't be too
Okay.
big a deal, but above that, you're looking at a crane and winch system from the top of the building, the next floor up, or some other telehandler on the outside of the building, or a
I see.
man lift with a glazier package on the outside of the building.
But when you're putting a like a 50 floor skyscraper, a
Yeah,
telehandler can only do so much going
right,
from the outside. That too, like you were mentioning, there should be no buildings around.
right. Yeah, you're limited on your space on the outside. They might be starting to work on the landscape or the curbing or the parking lot to keep everything moving at a steady pace so that they can get the building open. It's always an efficiency standpoint that the contracting company comes to us for. They've run out of space for their outside crane, or they need to speed up production on the upper floors, so they're going to tie up the tower crane. How do you solve that problem for them? So the quick solution is a compact handler or telehandler inside the building. So how do you get a telehandler inside the building? It's a really good trick.
Yeah.
Typically, they're quite large. They're capable of lifting 3,000, 4,000, up to 20,000 pounds. So how do you get that large piece of equipment onto that next floor where the slab that has been engineered has a given pounds per square foot? It's a real good challenge. They're always trying to go lighter and lighter because the cost of materials is significant. Also, how quickly can you build if you've got to make a 14-inch thick floor with a steel beam structure underneath it and all the shoring to hold it up? How do you then put something as heavy as a telehandler onto that new concrete? It hasn't had time to age. It hasn't had time to full cure to full strength. How do you get to that? How do you now install the glass? It's a real significant challenge.
When some of these builders approach us with this problem, we work with their engineers and then calculate the pounds per square foot, and then
Yeah,
we design the machine. Yeah.
we can give them the wheel loads on a typical pick. Say you're lifting 1,000-pound piece of glass out at 10 feet. We can give you the wheel loads on the front wheels and how far apart they are, and work with the structural engineer to figure out, okay, are we within your pounds per square foot? Do we need to come closer? Do we need to maybe go farther away to a different part of the floor to lift from? There's
Variables at
a lot
play.
of
Yeah.
variables that come into play for sure.
But we work with them and then give exactly that meets their specifications. That's
Right.
where we come in.
That's where we come in. We can even do a custom build if that's required.
Yeah.
Obviously, you can give them more options, different attachments, specialized attachments to do more than just lift the glass.
I
Maybe
see.
they have to lift a part of a beam into place that couldn't be done previously.
Okay.
We can give them those attachments to lift that into place.
And they're limited by if they want to be more productive, they can just put up another overhead crane. That's not possible. But with our compact handlers, they can have multiple working on different floors, and then they can get the job done much quicker.
You could have 2 crews, one working on each side
Yeah.
of the building and filling in the glass on that floor, and then they move up to the next.
Okay. So ours can typically fit in a freight elevator, and then that's already in place, right?
That is typically in place already. They have to get the guys up to the next floor, so the elevators are usually one of the first things put in. And typically it's a freight elevator in the same shaft where they'd have the standard personnel elevator.
Just for our audience, what is the footprint? It can fit through a standard door in the sense 36 inches?
Yeah, fit through a standard 36 opening door,
Okay.
36 inches wide.
Okay.
The machine is typically 34.5 inches and fits right through.
Open note to the listeners, if you can find any other equipment that's made stateside that meets all your qualifications, we would like to know about them, see how we can improve our product, or just get more knowledgeable about what the customers are looking for in terms of how we can make our product better.
Also contact us. We may have already got an
Yeah.
advantage. We may have already made a special attachment that works with our piece of equipment rather than buying one that's close
Yep. Yep.
and you're struggling to make it work for your application.
Yeah. And then you're putting a custom attachment or doing something to make that machine meet your requirement. Where we may have already solved that problem, or our machine is built in a modular way that we can just build an attachment with the exact loads that you want.
Right. We do all the testing in-house to meet all the industry standards. Our engineering is in-house versus, hey, you might be talking to engineering groups in some other country, maybe India, maybe Japan.
And some of the lost in translation happens so much.
Oh, even with sourcing components, it can be a challenge at times.
Yeah, I mean, completed machine with the calcs, yeah, that's going to be hard. So we are working with somebody in South Korea. They want to get our explosion-proof machines for aircraft, aerospace, and defense. But the way they state their regulations, the way we do it, there always has to be a translation.
Yeah, there's always a little bit of extra discussion that's involved for sure.
We don't want anybody to be unsafe just because of the language barriers or something that did not get translated properly. We thought this means this. No. If that is the case, we can work with you, get you exactly what you want, and then we'll put our name on anything that you
Math is universal.
give. Yep, yep. When it comes to explosion proof, there's like factory mutual, there's ANSI standards for area work platforms. For compact handlers, do you see which regulations apply?
Sure. If you're going to have a winch attachment, you need to winch stuff up to a different floor. That would fall under the crane standard.
Okay.
ASME has the crane standards. I believe
see.
it's B30 is where they start. Glass handler, that's a little different. That falls under the telehandler standard. So there's another standard for lifting glass or forks or special attachments that would fall under the telehandler standard. Then if you want to add on to that, you want to put a man basket on to be able to
okay.
install
You're right.
lighting.
We have a man basket.
We have a
attachment.
man basket option, and now we have to meet the ANSI standards A92.20 for a
Okay.
man basket. It suddenly becomes a small boom lift. So you have to meet all of those requirements as well, and we've gone through the work and we've made that happen.
It's not that our machine is versatile, can do all of the things, can do all of these things while subjecting the machine to all these other regulations. So you can't find a machine that is going through meet all these regulations and then provide you this one.
Yeah, it's difficult.
Yeah.
Yeah. Do they have all of these attachments capable? Have they gone through the testing? Have they self-certified, or have they had a third party look at the
Test it.
regulation and see that, yes, everything meets the requirements, signed off?
Yeah, folks can be like using one attachment much more. Glazing industry might be using almost exclusively the glass attachment, but that one time when you need a man basket, you don't want to be buying a new equipment or renting something. If you go with our machine, we just send you an attachment. You can just swap it whenever you feel like it. It's very modular in that sense.
Two guys can swap out any of the attachments.
Okay.
It's relatively simple.
So when folks are considering these types of equipment, they might have gone through one or two regulations, but is there a regulation that just comes out of left field for most of the folks that we have considered for a long time? We know that's the industry standard, but buyers out there may not be aware of.
I would say the ones that surprise people are the winch
I see.
and or the man basket.
Yeah.
You can put a man basket attachment on a telehandler, but did they do the testing and meet the requirements? Have they done the calculations for that particular attachment on that handler? That is the question. Is it safe?
We have like separate load charts for each one of these
Yes.
attachments.
Yeah, we've gone through all the calculations. We've set our softwares with our sensors to make sure that you're not going to overload the machine and possibly tip it over or damage something.
So the sensors will know which attachment it is, and
Yes,
then by that one, they can change the load. Okay.
correct. It changes the load chart. Now you have a new load chart that we've provided that you can
I
follow,
see.
and that's the max you can pick in that range.
The winch, mostly it's material, so it can be by the strength meeting physics, it can be higher. When it comes to man basket, we apply 1.5, the
Yeah,
safety
we just
factor.
do that's for the testing portion of the
Yeah.
program. We
Okay.
do a 1.5 on man baskets for sure.
Okay.
1.5 times, and it can't show any structural defects or have any issues, basically,
Okay.
that would say that, hey, you can't use this.
Our compact handlers all come with a standard hook, right?
That is correct.
So jib is an optional attachment.
That is correct. Say you have to get up and over something, like a beam might be in the way of, or a cabinet or some other structure that's in the way to get the part lifted into place.
Okay.
How do you accomplish that? Your straight hook, you can only get so close to the structure. If we add the jib on, now you can reach up and over horizontally over the obstruction
Obstruction.
and still lift the component up into place.
That's the jib attachment.
Yes.
So when it comes to, I'm sure, floor loading also means for different attachments. Which ones has the highest capacity, and then what does it mean for the floor loading? So we see all these like funniest videos. No customer has approached us that their lift fell through their slab, but I'm sure there are instances that happened.
I'm sure it's happened out there where they didn't provide that information. They wanted to go with a heavier pick.
Yeah, yeah.
That attachment might be rated for it, but did they provide the floor loading back to the structural engineer and go and say, hey, you want to lift this piece, your floor load's going to increase at that distance.
Yeah, yeah.
Maybe they hadn't thought of that. And, that's part of why we are internally set up to do that. The salespeople talk directly to us engineers, and we can provide that information, give them those hints. Hey, did you ask this? Did you ask that? Make sure that the floor load can handle it before we provide the machine so that they can plan accordingly.
So that's during the initial discovery call. But if the call with the customer goes beyond discovery, then we have a meeting with the engineering team, right?
Right. Right. To figure out all of the, hey, what's are the unknowns that we didn't think of, that the customer didn't ask?
And we ask all the questions, do the calculations. Once our engineering says this equipment is good for that floor load, you can take it literally to the bank. I'm sure we have instances of working with the structural engineers. I don't know what stage of the building it is, but what information do we typically ask them?
Typically, what is your floor load capability? How many pounds per square foot in the locations that you want to lift the glass or the beam or whatever else that you're lifting? What is your pounds per square foot in that location?
Okay.
That we can say, okay, the base machine at this capacity with that attachment provides this wheel load at each wheel at that distance apart. The overall weight of the machine at that pick, what's the front load, what's the rear load, what's the side load on, is one of the front wheels higher than the other? Is the rear wheel heavier than the fronts? We can provide that information and go, okay, you're within your pounds per square foot. Here's the calculation. Do you agree? And they sign off on it, say, yes, that's acceptable.
So for folks listening, could you elaborate something on what's called a Omni? Where does that name get derived from? We have an Omni version, and then we have something in research and development, something called Omni Light.
Typically, telehandlers and small compact handlers deal with your typical forklift drive system where the front wheels are stationary and it's rear wheel steer.
Okay.
So that's pretty common. Most of them out there, or they just push around.
Yeah, I see.
Ours
I
happen to
see.
be powered because we don't want the workers having to push a heavy piece of equipment. But that's pretty standard for us to have it powered. How do you get into tight corners where you can't swing the rear of the machine all the way around. Your tail swing, which it's called, is based on the front center line of the machine at the front axle. So we've developed what is known as omnidirectional steering, where we put steering on at least 2 wheels, sometimes up to 4 wheels. And you can now suddenly turn the wheels sideways and move the entire machine to the side
Oh, wow. Okay.
to be able to clear one obstruction or a jog out in the wall that you have to get around. You just turn the wheel sideways, move over, turn the wheels back straight, and now you're back in line with the wall again.
So that's not crab walk, right?
No, that's not crab walk. Crab walking is, say you have a kind of a diagonal hallway that you have to turn down,
Oh,
and
I
where
see.
you
I
can
see.
just get the machine down that and turn the wheels down the hallway, and now suddenly the whole machine will drive that way right down the hallway.
So when it comes to side loading, one of the things I heard for aerospace and defense, if they want to do something on the glasses of an aircraft, they don't have room to go back and then come forward. So it just moves side.
You can move sideways
Okay.
and pick the next piece and put it in place. Just keep moving sideways down the aircraft or the spacecraft and pick up the next item and set it in place. You don't have to back up and realign probably 5-6 times per pick. You can just move over, get in line, pick the item, get it close. You can even move the machine very precisely to the side and be able to place that particular glass or piece of equipment.
When it comes to precision, we have something called a 3-axis manipulator that can provide side shift that's like glass handlers. I think that is necessary because we don't want the glasses bumping into each other.
Right. For a non-omni drive machine, how do you get the glass perfectly in there when you've got maybe a 1/4 inch gap around the window or less?
I see.
How did you pick it perfectly and be able to, once you get it out through the hole and then start coming back in, oh, doggone it, I'm an
Yeah.
inch off.
We don't want the customer to like back off
Yeah,
and then come
how do you-
forward just to cover that
Yeah,
inch.
so we've developed a side shift that gives approximately 2 to 4 inches of side shift capability. So yeah, you didn't get it perfectly right when you went out. Not a problem.
Okay.
Just side shift it over. Now it's right in line. Pull it into place.
Machine is closed enough, you might not get it perfectly right next to it. You might be scared, given 2 pieces of glass, you don't want to be driving that close to another piece of glass with a heavy piece of glass. You get it close enough, and then you can just move the glass itself
Correct.
with using side shift. That is pretty handy. I'm sure we've
Very.
got compliments from our customers that is a feature they use all the time.
Yes.
So this omnidirectional. So we recently got interest from the data center building community, and then that is somebody who we are working for. So client names aside, can you allude to what they're doing with these machines?
Sure. Basically, they're putting up basically firewall panels,
Okay.
which are 2 pieces of steel laminated over some kind of insulation in between.
I see.
And you have to pick that panel up and build a wall with it over the steel beam structure. So how do you pick that up? Well, the glass manipulating companies that make the glass handlers have specialized pads for lifting that type of panel.
Panels. But you don't have a machine that can accommodate that.
Right. That's the other issue, is how do you keep moving and fitting these panels that interlock with each other? How do you slide them sideways into place? Well, there's 2 options. The side shift is an option,
Yeah.
but what if you're not exactly perfectly aligned with the wall?
And then the amount you have to shift is not that close. You might have to shift a lot.
Yeah, you might
Right.
have to move 4, 5, 6 inches.
Yeah.
So how do you handle that? Omnidirectional steering comes into play. You align your wheels with the wall,
Oh, wow.
and you just move the whole machine. It'll
So-
move the whole panel. Everything will move with it.
So the wheels, all 4 wheels are parallel to the wall, the structure.
Correct.
Oh, okay. Nice. So data centers, the time is literally money for them also. They're racing against time to put these data centers in place. And then this is something novel that has been that is being piloted by one of our customers. But if any other data center clients are looking at what piece of equipment can get me to build these data centers really quickly, so we are here. You can contact us. We can work with you to design a piece of equipment that can help you build your data center quickly.
Correct.
Okay.
Whether it's a specialized attachment for the panel or for a beam or a other piece of structural or a piece of operating equipment, we can help you out with that.
You can rotate the panel 360 degrees, 180 degrees. It can crawl sideways. I mean, there is like very, very few things our machine cannot do in the standard construction space.
And if you think you've got a challenge for us, give us a call.
Go for it.
We're up to the challenge. Bring it in.
Yeah. So when it comes to specialized equipment, can folks look at rental houses to procure something? I'm sure rental houses carry different type of equipment, but once you need something special, you might be out of luck.
That's typically where they're going to start. General contractors are going to contact their local rental house, go, hey, I'm lifting panels to place on a wall. And they'll go, okay, well, we've got a telehandler. You can put a panel lifter on a hook and lift your panels into place. We've got these other pieces of equipment, maybe another compact handler from an outside source. You can use that to lift the panels into place. But the question that comes into play is, have they talked to the structural engineer? Have their engineering group gotten in contact with that structural engineer? Hey, we've got green floor. Or, hey,
like you were saying,
the pounds per square foot is only so much. Does that piece of equipment really work there? Has somebody gone through and contacted the engineering group? How hard can that be if the piece of equipment is made in Italy? How fast are you going to get your response? And then how versatile is that piece of equipment? Is it really going to meet all your needs inside of that space for completing the building?
So all the compact handlers we've been talking about so far, indoor for some kind of paved semi-finished space. We also have a version with the tracks that operates outdoors, right?
That is correct. For lower level picks from outside, we can provide what is called our CH Tracks unit.
Okay.
And that has the same glass manipulator as the standard CH4 or CH6 that we would normally use indoors or on an industrial space. If you need tracks, we can help you out with that. If you've got a little bit of rough terrain, that's where this machine comes into play.
So the tracks can also work on floors that are not yet completed because that's okay.
Right. And we can do non-marking tracks if that be the case. If you don't want to use your heavy lug track that you're normally out in the dirt with, we can provide a machine with non-marking tracks for internal use.
So some of the things people look at when they're looking at niche manufacturing space is the CapEx is a little bit higher when you get customized equipment for you. But the OpEx is much lower when we go with our machines, because with the machines that you import, run-of-the-mill machines, what happens is once that machine breaks down, it cascades a lot of your costs. What if your job site is down for 2, 3, 4 days, sometimes more than a week? So the amount you pay in maintenance and then lack of parts and then service, that more than exceeds what you pay for specialty equipment here made in America.
Right. Parts availability comes into play.
Yeah. With that concludes the discussion on our compact handlers. Thank you for tuning in. Wishing everybody a happy Independence Day.
Thanks, everybody.
Talk to you next time.
Stay informed, stay protected.